Alright, welcome to this next video, guys. Today we're going to be talking about chance and probability. And the learning goal for this one is that students determine the sample space for simple experiments with equally likely outcomes and assign probabilities to those outcomes. Alright, and by the end of this, you'll want to be able to state the sample space for a particular trial and calculate the probability of a particular event occurring. Now, already there's probably some technical language there for you, but that's some stuff that we'll come across as we go through. All right, quantum probability. So some crazy stuff happens when we get down to a quantum level, which is the teeny weeny size in which atoms are behaving, right? And it turns out that you might be familiar, for example, with a hydrogen atom, which, and this is the most studied atom and its behavior in a quantum physics perspective, because it just has one proton in its nucleus, which is a positive particle, and it's got associated with that one proton has one electron that sort of goes around and around and around like this, which is a sort of a classical way of seeing it, that the electron kind of orbits around and around and around in this particular orbit that it happens to like being in. It turns out, though, on a quantum level, we can't be really sure where it is. And rather than saying that, yes, at any particular point in time, the electron's going to be somewhere around here, so there maybe, or maybe it's going to be here, or maybe here. Turns out that it might not just be on that orbit. That's just the most likely place to find the electron if you went looking for it. It could be anywhere from in here, okay, as it's going around. It could be over this side as it's going around, which is kind of weird. It could be all the way out here or all the way out here, but it's just that its most likely area is to be somewhere in here. It has a higher probability of being in there, but it has some chance of being just randomly out in the middle of nowhere, which is kind of weird, but it's how the quantum world behaves. We can't nail down positions and stuff perfectly, so we just have to go for like probabilities of things. Okay, so it gets kind of crazy when we're talking about atoms and things smaller than that even. All right, so probability has some crazy applications in science. All right, let's look at some of our key ideas. So a lot of this is vocabulary, so that when we're talking about probability, we're going to be on the same page and use the same kind of words, and you'll understand what the different sort of things mean. Okay, so firstly, there was that idea we spoke about before. So a trial is an individual repetition of an experiment. Okay, so let's say that we're going to experiment on the results of tossing coins, right? An individual one of those tossing of the coins would be a trial of the whole experiment of looking at tossing coins, okay? Whereas our next one is an outcome, okay? So an outcome is a possible result of an experiment, okay? For example, if we were to toss a coin, the coin could go heads, that's one outcome, and the other one is tails. Okay, so that would be the two outcomes that are possible from flipping a coin. All right, a fair coin. Okay, now, next one we've got to talk about is the sample space. Okay, so the sample space is the set of all possible outcomes from a particular experiment. So let's say your experiment is rolling six-sided dice, and you want to write down the sample space for that. So the way we do that is that we write S for sample space, equals, now we get to use these really cool curly brackets because that's how we denote sets in mathematics, okay? And you write in here all the outcomes we could get. So if you rolled a fair six-sided dice, you could get a 1, a 2, a 3, a 4, a 5, or a 6. And then we shut it off with some curly brackets at the other end. Now, that's how we write the sample space, okay? So that's something you need to be familiar with doing, being able to write that out. All right, now an event is a set of outcomes though, okay? So this is a little bit technical again. So for example, rolling an even number on a die is an event, okay? Or rolling a 2, that would be an event as well, okay? So that's usually when you're talking about, that's the thing you're gonna test. What is the probability of this event occurring, okay? Or sometimes it's, what's the probability that this event doesn't occur, all right? So sometimes it's both ways looking at it, but event is the thing you're gonna be looking for, okay? Right. So, and we would write that, I suppose, with PR for probability of the event. So it could be rolling even number. Okay? All right. Now, when we finally do measure the probability of some particular event occurring is some number from 0 to 1, which represents the chance. So our probability can't go any lower than 0, nor can it go any higher than 1. Okay, so in the middle here, we've got about 0.5, which also is 50%, okay, or half, all right? And so we would call this is sort of an even chance of something occurring. Okay, even chance. Then you've got here at about 75%. So that is a likely event. And here at 25% is something that would be unlikely to occur. Up at 1, you have something that is going to be definite. Okay, it's definitely going to happen. And here at 0% chance is something that would be impossible. Okay, so obviously that's 0%, and 1 is 100%. Okay, so we'll always be getting probabilities that are between 0 and 1. So if you're getting outside of those bounds, something's kind of gone wrong. Okay, now to calculate the probability of an event happening, we use the following formula, and it's important that now we're moving on to using a formula that you have to write that formula out like we have with our mean and with our mean anyway. Okay, so we write it PR, that means probability, and in the brackets we write the event that we want. Then we've got it's equal to the number of favorable outcomes divided by the total number of outcomes, okay? Now, because that's like 1,000 words to write or something, you are allowed to write instead PR, the event, is equal to favorable over total. Okay, I'm happy for you to sort of shorten it up like that, because otherwise the words you write just go sort of all over the place. Okay, so this one here is sort of the minimum thing that you've got to do as far as the formula is concerned. Okay. All right, as we've seen before on that number line, probability can be written as a fraction or a decimal or a percentage. Okay, it doesn't really matter, whichever one you're more comfortable with using, or whichever one your calculator gives, or what makes more sense with the particular data that you're dealing with, go with that one. Okay, there's two different types of probability we'll be worrying about. Now, there's theoretical probability. Now, that's something that's calculated without actually performing the experiment. So we could calculate the probability of the dice rolls without having to actually roll any dice. Okay. Similarly, with our experimental in the opposite way, experimental probability is calculated when we actually perform an experiment, a whole bunch of trials, then we collect that data and calculate probabilities from that data. Okay, in the worked examples, you're going to see how both of those turn out. Okay, right. So for each of these, we're going to list the sample space and then calculate the probability of the following situations. So rolling an odd number with a 6-sided die. So let's write the sample space. Whoops. So S equals curly bracket 1, 2, 3, 4, 5, 6. Okay, that's our sample space. Now we want rolling an odd number with a 6-sided die. So the probability of this rolling of an odd number, okay, is equal to the number of favorable outcomes divided by the total number of outcomes. All right, so how many times can an odd number turn up here? Well, we've got a 1, a 3, and a 5. So that is 3 favorable outcomes over a total of 6, which is a half, which is 50%. Okay, so you get a 50% chance of rolling an odd number when you roll a fair die. Okay, right, so here's another one here. So these are both theoretical probabilities. Okay, so here's another one, randomly selecting a vowel from a bag containing 26 identical pieces of paper, each containing a different letter of the alphabet. So first thing we're going to do is write out our sample space. And I probably should have thought about this first, but A, B, C, D, ... all the way through to X, Y, Z. Okay, there's our sample space. Okay, this little ... is a sneaky way of saying in the same way, keep going, right? So that's our sample space, and our probability of a vowel, okay, is equal to favorable over total. Okay, and there are 5 vowels out of a possible 26. Okay, and that equals 0.19. 0.19, so that's about, so a bunch of other numbers, 0.19, so that's about 19%. So a 19% chance of choosing that. All right, so there are our theoretical probabilities. Now let's have a look at our experimental probabilities. So a six-sided die was rolled 10 times and the results were collected. So 5, 6, 4, 6, blah, blah, blah. Now, we're going to have a look now at calculating the probability of rolling a 5 on this die. Okay, so we're not going to worry about the sample space because we know what the sample space looks like for these die. So let's have a look at how we're going to calculate this. So the probability of our event, so rolling a 5, is equal to favourable over total. Okay, now we look here, we've got a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 10 times, oh dear. So 10, and we rolled a 5, 1, 2, 3 times. So 3 out of 10 times, which is equal to 30%. Okay, which seems weird. 30% chance of rolling a 5. But that's the difference between experimental and theoretical probability. Okay, and this last one's even weirder, I guess. So now we're going to be looking at the probability of rolling a 2. So probability of rolling 2 is equal to, as before, favourable over total. Okay, now, how many times did we roll a 2? 0 times. So the number of favourable outcomes is 0 over a total of 6, which is 0%. So we're saying that based on our 10 rolls of this dice, we're saying that you have a 0% chance of rolling a 2, which doesn't make a lot of sense. But as I said before, that's the difference between experimental and theoretical probability. Okay, so a lot of that was probably some revision for you, but I hope that made some sense for you, and please come and ask me if you've got any issues or questions with that, and I'll see you at school. Thanks.